Okay, yeah, thanks for the introduction. Okay, yeah, as already mentioned, my topic is benchmarking surface heat fluxes, and I work with Jasper, David, and Christoph on this project. And I will start with a general background. So our general aim is to develop a framework for benchmarking land surface components of weather or climate models with special focus on ECMWF models. And there is already a Python package called LANDVER for this, which allows for the validation of soil temperature and soil moisture. And what we want to do is to extend this package for surface heat fluxes. And there are two types of surface heat fluxes, as visualized in the graphic. So sensible heat flux and latent heat flux. And they are driven by temperature or moisture gradients between atmosphere and surface. And they're influenced by, for example, climate and weather conditions, and especially also by the surface properties. So, for example, orography, and very important is vegetation and moisture availability. Yeah, and these fluxes can be modeled. So with land surface components of a weather or climate model. And for this, we use here ERA5LAND, which is one online, fully coupled with data assimilation. So, but the fluxes are not assimilated here, so it's still somehow independent. And it has a spatial resolution of 31 kilometers and the temporal resolution of 1 hour. And additionally, we use another model, short HYFS, or hydrological forecasting system, which is run offline and driven by ERA5 and contains the updated vegetation scheme. And it has the same spatial resolution, but the lower temporal resolution, just 6 hours. And these surface heat fluxes can also be measured. So that's a bit more complicated than normal meteorological stations. So for this, we use Eddy-Covariance measurements. This means that you have such a sonic anemometer with a really high sampling frequency combined with temperature and water vapor measurements. And a portal which provides such measurements is ICOS, the Integrated Carbon Observing System. And they have like all the flux towers in Europe. And these are really point measurements. And they have, in the end, the temporal resolution of 30 minutes. Yeah, and here you can see in the left plot the location of the stations in Europe. So they cover a nice north-south range. And on the right plot, you can see that when the network started in 1996, there were just 5 stations. But in 2020, we had now 67 stations. So, and we will use 2020. Okay, and yeah, as an introduction, an example for a general seasonal or also quite similar diurnal cycle for sensible and latent heat flux. So here you can see on the x-axis the month and on the y-axis the flux in watt per square meter. And you can see that on first order, this follows solar radiation. And the positive sensible heat flux means that we have unstable stratification. And the positive latent heat flux means that we have evaporation or transpiration from plants. And this is the usual case in summer and during the day. And you see in winter or also during night conditions, like we have slightly negative fluxes or close to zero fluxes. And this means in terms of sensible heat flux that we have stable stratification, or in terms of latent heat flux that there's condensation or deposition. Okay, yeah, then let's start to look at some results. So here we look at 0 and 12 UTC values. They should like be an example for showcasing the diurnal cycle. And we look at like a station and then the nearest grid point in the model. And on the left side, you can see the linear correlation on the y-axis. And on the x-axis, the stations sorted by their latitude. So from the southernmost to the northernmost station. And you can see in the different dot types, like you can see the 12 UTC and 0 UTC values. And you see for 12 UTC, both sensible and latent heat flux have really high correlation of more than 0.6. But for the 0 UTC values, the correlation is on average quite low, just below 0.3. And if we look now at the mean deviation, then it's the other way around. We have a low mean deviation for the 0 UTC values, which is due to that the fluxes are quite low in general. But because they are so low and close to 0, it's quite difficult to get a high linear correlation. But for the 12 UTC values, we have a high mean deviation, so up to like minus 130 for sensible heat flux. But because they are high and positive, we still have a good correlation. And yeah, so these differences in 0 UTC and 12 UTC measurements motivate to look at the daily average values. So this is now the same plot type, but the daily average over all these like 4 measurements like 0, 6, 12, and 18 UTC. And again, on the left side, the linear correlation versus the location of the station. And now you can see that on daily average, the correlation is more than 0.7 for both fluxes, and just a few Mediterranean stations have a really low correlation. And if you look at the mean deviation, we see that this is slightly positive for latent heat flux, which means that the model slightly overestimates on average the latent heat flux, and it's slightly negative for sensible heat flux, which means the underestimation. Yeah, and if we now combine seasonal and diurnal cycle, here's an example for one selected station in Finland. And on the left plot, you can see the measured sensible heat flux, so the month on the x-axis and the hour on the y-axis. It's interpolated, but just in principle, these 4 values we always consider. And you can see this clear maximum during summer for the 12 UTC measurements, and negative values during night or also during winter. And if we look at the mean deviation of the model from these measurements, we see again that during day conditions, we have this negative mean deviation, which means an underestimation. And during night, we have positive mean deviation, which means a slight overestimation. So in general, the diurnal cycle is not as strongly pronounced as in the measurements. But what we also see is that these absolute values are much higher in summer than in winter. And yeah, now this was all on this hydrological model. So if we combine this or compare this to ERA5, that's a big table, but maybe if we look first at the last row, for example, this is again the daily average values, then you can see that for ERA5 land, for sensible heat flux, we have a slightly higher linear correlation, but also slightly, in absolute value, slightly higher mean deviation. And for the latent heat flux, the values are quite similar. But the biggest difference is that if we look at, for example, 12 UTC, then the linear correlation for ERA5 is much lower than in the other model, which is probably related to that this is really an hourly resolution. So it's much more difficult to reach this high correlation on an hourly basis than on a 6-hourly basis. And so here would be interesting then in the next step to adapt the resolutions of both models. Okay, to sum this up, so what we did so far is we did the post-processing of the model and the observational data and the data exploration. And as showcased here a bit, we did the evaluation of some standard metrics for daily average values and the diurnal cycle. And currently that's in the framework of some Jupyter notebooks. And what we plan to do is to put this now in this actual LANDVER package, and add in this LANDVER package also the diurnal cycle and probably some slicing per vegetation type. And scientifically, it's interesting to compare the results and to the study here of Kral 2011, where they did a similar thing for ERA interim. And there it would be interesting to see how or if the models improve to this slightly older model. Yeah, so that's all. Thanks.
Thank you. Thank you very much, Laura. I think you are progressing so much. We are quite impressed about your first results. And if everyone has a question about the project benchmarking, please, you can add your question in the Q&A chat. And
yes, Satina, there's already a question in the Q&A. Can you see it?
Well, it's just a correction.
Yes, it was one of the mentors, David. Yes.
Okay, yeah, sorry.
Yes, David commented that you're comparing ERA5, not ERA5 land.
Yeah.
Offline.
Yeah, thanks for the notice. Yeah.
Yeah, and how is your experience with your coding experience with your mentor, Laura? Can you share a little bit about it?
Yeah, it's definitely really good. So I really like that we meet regularly and discuss the progress. And also it's nice to like that the data is already provided and that you can directly start with the programming and I don't have to do too much data work. So that's really nice. Yeah.
Okay, fantastic. Okay. We are looking forward to your to the end when the coding phase finish and you can share with all of us your well safe progress the project. Thank you.